The rollers for this 1x30 belt sander grinder, there'll be two of them required. Be made out of 2-inch diameter, 6061 aluminum round stock, 1.65 inches in length. We'll be using the same bearings I used on the 2x72 belt grinder, the R8ZZ bearings. You'll need 2 of them per roller for a total of 4 bearings. The outside diameter, or the inner dimension of the outer race, is 0.990. So we want to bore all the way through 0.990 for that. Then we'll come back in a moment and put a shoulder of 1.125. That'll leave 1/1000th interference to press these bearings in. We'll cover this belt track a little later. But for this through bore in there, I have a spindle that I made when I did the 2x72 belt grinder. Since I'm using the same bearings, this inner bore that I'm fixing to make in this one, I'll size it. It's 0.990, but instead of trying to measure it with the inner calipers and micrometers and whatever, I'll just go for a fit on this spindle. I have one of the pieces in there already and have bored a 5/8 inch hole in that. So what I'm going to do now is start boring this, and it'll be a pass-through bore, of course. And I'll continue this process, and I'll bring you back when we get a little closer. All right, I think we're within about 10 or 12 thousandths now, so I'll take 10. And I'm just going to keep taking a couple thousandths at a time until I've got a good fit, and that 10 did it. That's right in there. Okay. So now we want to take a shoulder off we've done our through bore, 0.990. Now we want to do a bearing shoulder to 1.124. All right, one dimension I failed to put on this list that I'll add later as I keep adding dimensions to this documentation. But we need to go 0.313 deep. The bearing thickness is 0.3125, so we want to be sure we are at least as deep as the bearing is thick. So I have carriage stop set at that now. And this is not going to be very much at all. This is another situation where I'm going to bore just a little bit and measure. All right, I'll bring you back when I have that to dimension. All right, we want 1.124. We want to get a bearing interference there of about 1/1000th. And that looks like about 8 more thousandths to go. Off the diameter. I'm just going to take 5 and keep measuring a little bit at a time. Of course, there is some spring in the boring bar. That's 0.12305. I really don't think I can cut any closer than that. And being aluminum, I'm sure I can press that in. I will put these in the freezer and the refrigerator for just a little while to draw them up just a little bit. But that's going to press in there nicely. I will chamfer that edge just a little bit there. Alright, that's got that lead in for that bearing chamfered a little bit. Hopefully you can see in there now what we have is a through bore, and then we have a shoulder for the bearing to press in on. I'm going to turn this around, do the same thing on the other end, and then I'll do the entire process to the other roller. Alright, I've got both of the rollers bored out through the center and got the bearing shoulder machined on both ends. I've revised this sheet just a little bit to include some of the information I left out, such as the bearing shoulder was 1.124 wide, 313 thousandths deep. Now, these rollers will have a recess in them for the belt. I went ahead and did one of them because I figured I could show you better than I could explain it to you. But this is what the finished roller will look like. This recess right here is 1.2 inches, which if you stuck with the 1.65 length of it, that means 225 thousandths off of each side, from each side. And the recess diameter, the finished diameter in here, is 1.6 inches. Remember, we started with 2-inch material, so we want to take 400 thousandths off the 2-inch diameter. As I said earlier, I've still got the spindle that I used making the rollers for the 2x72 belt grinder. Those rollers were longer, so I've just made a simple bushing to slide over that part. Mount that on there. This is the way we're going to hold this in there so that we can cut that groove in the middle. Now, to start that groove, I'm going to do it with the parting tool. First thing I'm going to do is just I'm going to get a 0 on the outside diameter, so I'm setting the x-axis on the DRO to 0. Now, coming off off of this inner edge here, now I'll set the z-axis DRO to 0, and as we said, 225 thousandths come in. Now I'm going to plunge 400 thousandths in there, or I'm going to plunge 200 thousandths in. My DRO will read 400 thousandths, which is what I'm taking off the diameter. Double check the 0 on the x-axis, which is right on. And that's 400 thousandths on the DRO. Alright, so I'll come down here to this end. Do the same thing. 0 out the Z. Come in 225 thousandths. And plunge in on this side. There may be another means. I tell you what, let me move the camera around so that you can see the way I'm going to take this center out of there. Alright, you can see the 2 grooves I've cut in there. And now I've got just a regular right hand cutting tool, turning tool. And I'm going to set the, just touch, set the center on that, or set the 0. Of course, we're going to mill out. We're going to turn out to the bottom of that groove, but that just gives me a reference. So I'm going to plunge in without getting on this shoulder over here. And of course each time I'm going to have to plunge a little bit. I'm not sure that you could get away with doing this in some hard steel. And I guess I could have done this with plunging the parting tool in, moving over the width of the parting tool and continuing. But this worked very well on the first roller. All right, this should come down to our 400 thousandths. Two-hundred thousandths off the radius, of course. And that clean to the bottom of that groove. Just a little cleanup pass. Now, as you can see, that has left a bevel on that end. So I'm sure you know what I'm fixing to do. I'm putting the left-handed tool in now. And just to keep an eye on it, I'm going to touch that off again. Reset the DRO so I'll just know when I'm getting close. And I want to reverse the feed on my lathe this time. Alright, this should be our finish pass here. I'm going to go until I just touch that existing, which is within 2 thousandths on the DRO. And clean up that edge. Now while we're right here, even with that tool, come back in and just touch off. And take just enough to clean that up. I'll put the chamfering tool on and clean up all 4 of those edges. Alright, there is another machine roller. All we have left to do now to this roller is put the bearings in it. I suspect it's going to be kind of worn. Yep, it's kind of worn. Alright, I'm going to turn this around. I'll cool it off. Then I'll turn the camera around and we'll press the bearings in. I've got a 20-ton press over in the corner of the shop over there, as you've seen in some of the other videos. But it's my 2x72 belt grinder is sitting in front of it right now. I've got to have some more space in the shop. So what I'm going to do is use the vise on the mill. I wouldn't do this if it was a very hard press in some steel, but this is just pressing some bearings in aluminum with only 1/1000th interference there. And I didn't have to put near the pressure that I would ordinarily put on the vise clamping down workpiece in here. Doing this one at a time just to be sure that they're lining up. And I don't guess there's anything in the shop any flatter than the vise jaws. So there we have the rollers. That's the 2 rollers done. The next piece we'll work on, I think, will probably be the drive wheel. Next we're going to work on the drive roller. Of course, only one of them is required. It is the same material, the 2-inch diameter, 6061 aluminum round stock, length 1.65, just like the rollers were. But this will not, of course, will not have bearings in it. It will have an internal thread to match my grinder. My grinder's threads are 5/8 of an inch by 11 threads per inch, which we're going to drill and bore to 0.532. We're going to have a thread depth of 0.750, so it'll be a blind thread in there. Then there'll be a recess on the end of it, same end that we thread, of 900 thousandths and 75 thousandths deep. This is the piece that drive roller will set on. We'll need just a little recess in here, 0.9 inches wide, and a depth of 75 thousandths will clear that. And I don't think I need to drill a pilot hole for this. Get the DRO up. I'll get the tailstock up and zero out the DRO on the tailstock. Remember, we said we wanted to go in 750 thousandths. A 5/8 11 calls for a 17/32 bit, which I do not have. And the next size up bit I've got will be too big for this. So I'm going to, after I flatten out the bottom of this, I'm going to put the boring bar in and finish this out, or finish it out to width with the boring bar. You've seen me use this flat end drill bit in other videos, but all this will do, the purpose of that is just to give me a flat, take out that 60-degree angle that was at the bottom of the drill bit there. All right, I'm going to bore that out to the diameter, and the diameter again is 0.532. It's what we need for threading. And I'll do that off camera and get the change gears in as well to do the internal threading. All right, a couple more things I needed to do before I put the change gears in though. Need to set the recess width, need to cut that out, 900 thousandths, and the depth, 75 thousandths. And remember, that is for this piece that the roller will the drive wheel will actually set on. To get that width of 900 thousandths on that, I'm going to use the boring bar and set 0 over here, move over there, then get half of it just to pull back to the center, and then work 450 thousandths off of that center. Also going to use a carriage stop for the depth on there. So first thing we'll do is 0 out the DRO on that edge. And for what we're doing here, that's this is plenty close enough. So I've got the DRO zeroed out. I'll pull it up to this edge and go half of that. So that should have the pointer on my on the boring bar at the center. And now we want to come 450 thousandths, and I'll just put a witness mark there. It'll actually be 900 thousandths since that's what the DRO reads on the diameter. And hopefully you can see it on there, but all I did was make just a little witness mark so I know where to work to. Now for depth wise, 0 out the Z-axis and bring it in to 75 thousandths. And set the carriage stop. And that's up flat now. So what I'll do is get the compound set and put the change gears in, and we'll cut our internal thread. All right, I've got the camera backed off just a little bit so that hopefully you can see what I'm doing over here on the cross slide and the compound. I have the compound turned to my 29 degrees to this side of center. Have the threading tool, internal threading tool mounted. I have a carry stop set down here just before I will hit the bottom right there. So what I'm going to do is cut that thread. This is a 5/8 11, excuse me, and a standard bolt from the hardware store is 5/8 11, so that's what we'll use to test the fit. All right, I'm back at 0. I'm going to advance the compound. Wait for the number to come around. Cross slide back to 0. Advance the compound. And I'm watching my carriage stop. Y'all watch the threads for me. I'm watching the carriage stop. All right, I'm going to continue that process and bring you back when we get close to the end. All right, I think I may have about one more pass to go. I'm going to cut down the amount that I'm taking off on each pass. This is aluminum, so I was turning the compound about 6 to 8 thousandths at the time, and I've cut down to about 4 thousandths now. And we'll measure or we'll test between each pass. And I'm going to make a spring pass on that one. Got to bring my compound back to 0. All right, let's see what that does now. And that's starting, but not quite there. Bring a compound back to 0 and advance just a couple thousandths. And make a spring pass. Maybe 1 more thousandths and a spring pass on that. All right, that's a good fit in there now. And the thread will go to the bottom. So I'm going to remove the change gears. Then, just like we did on the other rollers, we need to cut a track in here for the belt to ride in. To remove this drive roller, we'll need some spanner holes in it. Now, I just added this to the specs down here. What this needs for the spanner wrench that came with the grinder I'm using, I need 2 3/16 inch holes. It's 3/16 inch diameter, 1.2 inches apart, 1.24 inches apart, and 0.25 inches deep. All right, using the edge finder, we're going to find the center now. Zero out the X. Now X 1/2. Bring the DRO back to 0. And for now I'll lock the X down. Now we'll find the center of the Y. All right, now we'll take the drill chuck out and replace it with the collet and put the 3/16 end mill in. All right, we said those holes were 1.240 apart, so that's 62 thousandths on each side of 0. So move the DRO. 620 thousandths, excuse me. 620 thousandths to this side. And 0 out the Z-axis. We want to go 1/4 inch deep. There's 250 thousandths. Now we'll move to 620 thousandths on the other side of 0. And that sure doesn't look right. But it is. Okay. That's why you don't always trust your eyes. All right. Now we'll go back over to the lathe and put our tracking guide in there. To cut this belt groove in there, I'm going to hold it on the bolt that we use to test the threads with. I cut the head off of it. But I put that in there and I saw there was a lot of run out in this bolt. So what I'm going to do now is put just a little bit of a starter in here, just something to run the live center in to maybe help take some of that run out. It's not extremely crucial, but I'd rather that belt track be as straight as is easily feasible to get it in there. Still just a little bit of visible run out, but not that much, not near what it was. So now, just like before, we'll find our edge. All right, let's see if that spanner wrench is going to work now. And it did. Okay, carry this over there to the bench. I think probably the next thing we need to work on after I cool that off is the bushings to get all the rollers to the same height.